A very pleasant morning to one and all. In previous class, we have discussed about the digital imaging and the sampling process, followed by the computational techniques and what are the levels of the computations, namely low level computation, intermediate level computation, and the high level computation. In today's class, we are going to discuss on the topic of feature extractions. Okay, let's go into the topic. Let's delve into the fascinating world of feature extraction in the context of computer vision. Feature extraction involves identifying and representing distinctive structures within an image, which serves as vital inputs for various downstream tasks. Here are some of the essential aspects. Low level features, which includes edges, corners, and texture descriptors. Edges is nothing to detecting the abrupt color changes, representing the object boundaries. And what are the corners? Identifying points where gradient changes significantly, useful for tracking and matching. Texture descriptors is nothing but capturing the repetitive patterns, example fabrics or natural scenes. Followed by the intermediate level features is nothing to followed by the contours representing object boundaries as curves. Blobs is used to identifying regions within the similar intensity. Ridges is nothing but detecting elongated structures, example blood vessels in medical images. At high level features is nothing but object descriptors representing the entire objects, example of histograms of oriented gradients. And LBP is nothing local binary pattern capturing the textured informations. Scale invariant feature transformation is used for robustly detecting the key points. And what we are going to give is we are giving the raw data and we are going to feature the extraction, and with the extraction we are going to into the modeling, followed by the thresholding and the edge detection. Let's explore the concept of thresholding in the context of machine vision. Thresholding is the fundamental technique used to simplify the grayscale images into binary images by classifying each pixel based on its intensity level compared to a predefined threshold value. The thresholding basics is nothing but the major objective of the thresholding is to separate an image into two distinct regions, the background and the foreground. The binary image, the output of the thresholding in a binary image where each pixel is assigned either a value of 0 and 1. In this, 0 is represented as black and 1 is represented as the white. Let's see an example with it. Suppose we are having an image histogram with peaks near intensity levels of 40 to 180. By selecting an appropriate threshold, for example, we can take it as 90, we can divide the image into two distinct regions, one containing darker pixel and another containing the lighter pixel. Mathematically, if the threshold value is denoted as t, the segmented binary image g of x comma y is computed as follows: of g of x comma y is equal to begin cases of 1 and text if f of x comma y is greater than t or 0, and text otherwise if the end cases. Threshold is widely used for tasks such as object detection, image segmentation, and feature extraction. It simplifies the image representation, making it easier to identify and isolate the objects of the interest. And followed by the edge detection is the most fundamental technique used to identify the extract important boundaries and contours from digital images. What is the edge detection? An edge in an image represents a significant local change in intensity. Edge detection is the process of identifying these edges. It plays a crucial role in various computer vision tasks such as object recognition, image segmentation, and the feature extraction. And why do we need the edge detection? The need of edge detection is to find the discontinuities in depth surface orientation, illumination variations, and material properties lead to changes in the image brightness. Edge detection helps us identify the set of curves that indicate object boundaries and the surface marking. By applying the edge detection, we reduce the amount of data to be processed while preserving important structural properties of an images. Okay, thank you.